Hello everybody, I'm Alexey Karabarov, the organizer of SF Scala, and here we're on the location at ACINQ, which is a company using Scala, and also this is a joint meetup with SF in Tech, a meetup we started recently to explore engineering technologies behind modern financial technologies setups such as Bitcoin and blockchain and risk and fraud, and we happen to have a lot of these companies in our meetup, so we kind of focus on this. And today with us we have Fabrice Drouin, the CTO of ACINQ. Welcome, Fabrice.
Thank you.
So we are here following scaling Bitcoin, right? Mm-hmm. And maybe you can tell us a little bit what ACINQ does and why it's important for scaling the Bitcoin ecosystem.
All right, so we're a small Bitcoin startup. We started 2 years ago, and we work on the Lightning Network. So the Lightning Network is a scaling solution for Bitcoin. Mm-hmm. It solves the throughput problem you have on Bitcoin, which cannot handle more than about 10 transactions per second for the whole world. So it's a huge problem. Lightning is what people call a second layer solution. It is based on Bitcoin and it's on top of it. And basically it's a clever protocol based on updating transactions that you do not publish.
Right.
And creating a peer-to-peer network of payment channels that can have basically an unlimited throughput because transactions are not published and payments are routed.
Right.
So it's a very interesting solution to the scaling problem we have on Bitcoin. It's an open source project, it's a community. Everything is open source and public. You have specifications on GitHub, you have mailing lists, RSC channels, and right now we're about to release the first version of the specs and to have a first interop demo on mainnet with real money between the three major implementations of Lightning. So there's us, there's Lightning Labs just right here in San Francisco, just a few minutes away, and Blockstream also working on implementing.
Also local company.
Yeah.
Right. So you guys use Scala. I think one of those other guys uses Go.
Yes.
Which is Lightning?
Lightning Labs uses Go and Blockstream uses C.
C and C++. Right?
Yep.
Okay. So first of all, right, I'm completely new to the space. So I went to scaling and it struck me how complex the Lightning network is, right? Basically the description they gave in training and in the main conference is, and correct me if I'm wrong, you basically establish a channel so you plug into the main blockchain it's at a few points. First you open the channel,
yes,
and you post the collateral, it's like an escrow account. So you say how many coins you're going to commit to this channel,
yes,
right? And then you transact within the channel, which is private, which is off-chain.
Yes.
And then finally close the channel, and then you publish the final balance, right? And so basically there is a whole bunch of questions, as I understand there are intermediate states, right? So basically every transaction is a state, and you publish the state in the peer-to-peer network.
You publish, basically what Lightning is about is, suppose we open a payment channel between ourselves. So I fund it. So I will create a transaction that sends me, for example, that sends 10 Bitcoins to a multi-sig output, which is something that you and I must sign if we want to spend it. It's like a joint bank account. And we create what we call commitment transactions. They spend the funding transaction. They are valid at all times. They're signed by the both of us, so they're valid at all times. But we don't publish them. So when I open the payment channel, I send 10 Bitcoins to that multi-sig address. It is published. It's on the blockchain. And we each have a commitment transaction that spends from it. Mine gives me back my 10 Bitcoins, and yours gives you 0 because I am funding the channel.
Right.
And what we'll do then is update how much our transactions give to us, how we split the balance of the funding transaction. Suppose if I want to pay you 1 Bitcoin, we will update our commitment transactions, and we'll end up with, I'll have a commitment transaction that gives me 9 Bitcoins and 1 for you, and you'll have a commitment transaction that gives you 1 Bitcoin and 9 for me. And we will keep on updating our commitment transactions, but we don't publish them.
Right.
We could, but we don't.
Right.
And when we want to close the channel, we agree on what the final amounts will be, in our case 9 and 1, and we publish a closing transaction, and it's over. It's back to the blockchain, it's back to our own Bitcoin wallets, and we can do what we want with it.
Right. And so the the promise of scalability here is that you don't overload the main blockchain.
Yes.
Every intermittent transaction. And also there is supposedly a peer-to-peer network. So again, correct me if I'm wrong, I'm a new guy in this space, right? So I was not indoctrinated with the blockchain context and the fact that it's basically the major problem is scalability. It strikes me as extremely complex, right? So my first reaction, is this going to work for end users, right? So I'm at the, pharmacy, I'm at the supermarket, right? Suppose, let's say basically want to replace Visa or MasterCard with blockchain. So you basically want to tell me that this is a way for the merchant to transact with a bunch of customers. Right? So we want to replace people in the supermarket. So let's say I'm coming in with an iPhone, right? So I am very dumb. Like I'm not, I cannot create a website even, right? So imagine that basically this is much beyond me. So how can you implement this at the end user application where none of this is comprehensible to the user? What happens with Alice? So Bob now is not a person. Bob is a supermarket, right? So basically, can you imagine what will the end user setup look like where it becomes easy, right? Where I come and I swipe my phone or I shake it, I point it at something.
Yes.
I don't know anything about anything, right?
It's a good question. One of the challenges for Bitcoin is UX and how to make it simple for users to use.
Right.
So right now, if you want to pay something with Bitcoin, you will typically scan a QR code that says how much you want to pay and the final address where you want to send the money to. And Lightning will work like this. If you want to buy something, you'll see a QR code which encodes a payment request, and the payment request encodes the amount and the destination. So you will scan that QR code with your phone, and almost instantly, it takes maybe 2 or 3 tenths of a second. You'll see that you've paid, and the merchant will see that they've been paid. So it will be instant.
On the Lightning channel.
Yes.
But does it mean that my wallet has to have a sufficient balance, and I will so it will be the end user who will fund this channel with the merchant?
What we think is, at least to start with, Lightning we will use for small payments, a bit like your wallet,
right,
and your bank account.
Right.
In your wallet, you don't have that much money.
That's right.
And you use it to pay for small things.
Exactly.
And we believe that at least to begin with, Lightning will be used to buy cups of coffee or small things in supermarkets, and so the balance problem won't be an issue. You will always have enough to pay for things you want to pay with Lightning. Okay,
so explain to me, right? So let's say it's Starbucks. So Starbucks is a very digital, advanced company. They speak at Scale by the Bay conference we have in 2 weeks at Twitter. They use Scala. They're very advanced. They're very awesome. So they can certainly implement the server for this, right?
Yeah.
So, but now I am the user. So I come into the coffee shop. So latte in the US costs about $5, right? So it's expensive, but I like it. So I come and I'm willing to pay. So when I wag my phone at the cash register, do you want me to fund the channel for how much?
No.
For $5, $10, $20? How much should I effectively put into this Chrome?
What I believe is that users will typically open maybe 3 to 5 channels with different nodes, with maybe the equivalent of $30 to $50 on each channel, and they will use them to pay for like coffee. And once a channel is empty, they will close it, get back whatever is left on it, and maybe use it to open a new channel. But basically, you will always have a few channels for about $200 when you aggregate what you have in the channels, and you will use them to pay for small things. Okay,
so effectively you commit, you prepay.
Yes.
Right? So, this works great, right? Like, I know that for sure I'm going to spend every day at least $5 or $10 for coffee, so I can give you $50 in advance, knowing that I'm gonna buy this coffee?
Like because people say that money is locked in Lightning channels. It is true, but you can always get it if the other side of the channel is responding. You get your money back instantly.
Mm-hmm.
If I have a channel with you and I want to close it, and you are still responding to my closing messages, then the transaction that will be published will be usable right now.
Yes.
If for some reason you stop responding, you go away, your server dies or whatever, then I will publish my commitment transaction and I need to wait a bit before I can spend it. But like typically I'll wait 1 day before I can spend it. So it's with small amounts, it is not really an issue.
Yes.
But you would not create a channel just before you want to pay for something, because you still need to confirm the funding transaction, and that takes about 1 hour now. So it is not practical to open the channel when you need it. You need to have a few channels open at all times.
Right. Interesting. So typically, right, if I know that I'm a customary kind of coffee drinker, right, I want the channel open with my favorite coffee shop. But you say that the first time I do this, I should plan in advance, because I'm catching the ferry, right? So I buy my coffee before the ferry, 10 minutes before, and I'm running to the ferry. So this case is not going to work. I need to plan.
Yes, but the thing is with Lightning, that's a huge change compared to the payment channels that we had before. Is it's a network of channels, and you can pay anyone on the network. So you don't have to open a channel with Starbucks or Subway or whatever. If as long as you have a channel to a node that is connected to Starbucks, you can pay Starbucks.
Okay.
Which is why you will only need maybe 3 channels to pay basically everyone.
Okay.
The channels we had before, you had to open a channel with every merchant, which was not practical.
Right.
It's not true anymore.
And Visa or MasterCard charges every single merchant for the terminal. So okay, let's consider this scenario of like several hubs. So let's say Walgreens is a big pharmacy chain here, right? So I have a channel established Walgreens, and it's not urgent, so I run out of paper towels. So I go at night to Walgreens, and kind of my kids are asleep, so they're open 24 hours. So I'm willing to wait, right? So if I want to establish a channel with them, I waited an hour. I know it's confirmed. I went there, I paid for the paper towels, and I committed $100 in there. So next day I go to Starbucks and I realize I want coffee. I don't have the time. I'm catching my ferry, but now I know that I have the channel of Walgreens.
Yes.
So how will Walgreens channel work in case of Starbucks? What do I need to do? What needs to happen in the network that I come to the terminal to Starbucks? It's the first time I want to do something there. How does Starbucks know that there is a channel with Walgreens and that I'm going to be paying through that channel first to them?
Because routing is a hard problem, but we'll start with a gossip routing system where everybody knows as a complete map of the network. So if I want to pay Starbucks, my phone will have, or my Lightning wallet will have a complete map
of everything.
Of the Lightning network. So I will find the route to Starbucks.
Of global Lightning network?
Yeah.
You know every single terminal?
Yes.
Okay.
You know every channel.
Every channel?
That wants to be published.
All right.
You could have hidden channels.
So if you have 7 billion people in the world who are on the Lightning network, there should be 7 billion times number of channels to open in this network, at least, plus all the intermediate hubs.
Not necessarily, because for example, end users don't need to advertise their channels.
Correct.
So
you mean inter-merchant channels? You want channels, the hubs which are willing to pass through payments?
Yes.
Okay.
Like the payment request includes routing information. So you could very well not publish your channel because you're an end user and you will not route payments, but you will include routes to a few nodes in your payment request, and this should be enough, hopefully, to find a route to you. And
so you don't need the leaves
for you to find a route to the merchant you want to pay.
Only the nodes, not the leaves.
Yes.
Okay.
And right now we know that broadcasting and having everyone have a complete map of the network is not going to scale a lot. It can handle maybe dozens of thousands of channels, maybe a few hundred thousands of channels, but it will be limited. But it's good enough to start with. We believe we will be able to bootstrap a Lightning network that people can actually use, and there are optimizations such as not publishing leave nodes that will let you use Lightning even with a lot of people. Some people say that Lightning will be centralized because obviously huge hubs where everybody is connected will handle a lot of traffic.
That's right.
But it's not because this works that something else could not work. So I don't believe that Lightning will be fully centralized because if you compare it to mining, for example, everyone can mine, but if you mine at home, you will never, ever find a block. So because it's there's a threshold, a barrier to entry. It doesn't exist with Lightning. Anyone can run a Lightning node, and anyone can connect to it and start paying things. So there is absolutely no barrier to entry, no threshold effect that will prevent you from effectively running Lightning nodes.
Okay. Is there any way for the merchant, or and let's say I'm coming to Starbucks, and I'm a user, I'm protective about my privacy. I don't have the Starbucks channel directly, but I have Walgreens, I have Safeway. Basically, can I choose as the user, and can the merchant choose the routing? Like, is the routing completely round robin, or is it preferential? No. Do you have to say in how do you want to route?
We use to begin with. We will use source routing, which means you choose the route to the merchant.
The customer.
Yes.
Okay.
Completely. It works a bit like the Tor network. You will compute the route, and nobody else can change it. So if you don't want to go through specific nodes, you can avoid them if you want.
So the first time I come to Starbucks, if basically you mentioned that some kind of routing choices will be presented to me. Like I'm on GPS, I have multiple routes to destination, right? So better GPS gives me like, here's the route through highway, here's the route through local streets, no highway. Here's the route of no U-turns. Here's no unprotected left turns. So you're basically saying that will I be seeing this, or will it's like, if it's too overwhelming for the customer, will it be hidden?
I think it will be like advanced settings. Most people don't need to see the route and how it works, but since it is computed locally, you could very well ask for your wallet to display the route, and you could very well decide to add rules like don't go through these nodes, or
Right, because somebody can basically set up a trap node which will be accepting all routing requests, right? Like, let's say NSA wants to intercept all the payment requests and collect all your data. So they set up a very cheap node, they'll fund it, and they'll route your data, right? In order just to know who you are. So
yes, but it's not that easy, because we use there was a lot of attention to privacy issues, and the traffic is encrypted, authenticated, and when you are relaying payments, you don't know the origin or the destination of the payments. You know where it comes from, the node that gave it to you. You know who to give it to. That's all you know. You don't know who started that payment, and you don't know the final destination.
Is it
the
Bitcoin
payments.
Address, or is it like separate Lightning network?
It's the addressing system is different. Basically, every node will have a private key and a public key, and the public key is used to identify nodes. The address of a node is its public key.
Okay, so I think we're short on time, so I'll ask you why Scala, right?
We've used Scala before. We use Scala mostly because it's a nice language, and the JVM is one of the best runtime there is to build servers. It's underrated because it's Java and it's old and it's enterprisey, but it's extremely good for as a platform for running servers. And I think that's why we chose Scala.
So I'm a huge fan of French School of Programming Languages. Right? So my first big language I fell in love with was Ada. which was still in Soviet Union. So it brought me all the way to the US. And then I programmed in OCaml, which I think people still learn in school. So how does this kind of context, functional programming with OCaml, influence your choice of Scala? Is this that a lot of folks who know OCaml can switch to Scala easily, for instance?
We actually come from Java.
Okay.
We didn't use functional programming languages a lot before Scala. It was the first one we used. And our choice was mostly driven by wanting to keep on using the JVM and having something that is less clumsy to use than Java. So we started with Scala as a better Java for the JVM.
Did you have to learn OCaml school yourself?
No.
Or any other team members of ACINQ?
Don't think so. We focused on algorithm design and computer science, but I never had classes that dealt with functional programming languages.
So it's a purely Java kind of, better Java kind of simplification, Java environment stuff. So how do you feel, I just went to scaling, right? Like this Bitcore C++, some examples are in Go, right? So I certainly felt in the minority, and when I talked to some of the elders, I feel like, they said like, this is a very conservative network, right? Like this is basically C++ done by folks who did security for 20 years. So they have the processes, they are pretty comfortable that they can do stuff even in C++ because they have very rigorous testing and very slow moving process, right? So how do you feel kind of being surrounded by the sea of C and sometimes Go?
Scala is not as I guess widespread as people thought it would be 5-6 years ago. So we're used to having something that is a bit exotic, but it's not a problem because for low-level things, C and Go are really nice, but Scala gives us access to the JVM that is a very good platform, and also the tooling and libraries that you get with Java, and that is extremely useful. There's a Java library for absolutely everything.
Yes. And
popular Java libraries are used by millions, I guess actually millions of users, so they're pretty good, they work, and it is really a good platform for what we're doing because we can prototype very quickly. Whatever we need, we find. We never spend time redeveloping low-level stuff that is not necessary for what we do because we always, whereas it is cryptography, networking, whatever, or even computing graphs and finding routes. There's always tools we can reuse. So we don't feel like outcast because we use Scala. It is exotic, but it really works as a development platform.
Yes, and it's, in the US, it's every year it's less exotic, right? So I can tell you, right, like we, around the 5th year, Scale by the Bay conference now, and every year we have new companies coming in, and all companies doubling down. So, Apple is a huge user of Scala. So it's series written in Scala, Apple Maps, right? So it's not really exotic anymore. So I think you're in a good group. So last question I have, I'm really curious about this whole ecosystem because it's really, to me, it's kind of Renaissance technology because you need to know psychology, right? Because it's a people-facing system. In the end, people will make decisions, right? Then it's math and cryptography and computer science, right? So, French School of Math is obviously very well established. So, do you think you guys have an advantage in the way that French education is very strong in math, it's very strong in theoretical computer science and algorithms? Do you think you guys, by virtue of picking Scala and having your team in France, you are kind of competitively positioned to work on this Lightning Network?
Maybe not because of the math and things, but I think mostly because Scala and the tooling we have enable us to build things really quickly. I would say that compared to other teams working on Bitcoin, we really have tools that enable us to try things extremely quickly and without having to throw away what we've done when it comes to changing it into something we can use in production. The development environment is really good. As for the math and cryptography in France, that's one of the things that I think is really sad, but we have a lot of mathematicians and cryptographers, but the French are not really interested in Bitcoin right now. So
there's a lot of academics, right?
Yeah,
and they're not different from
we are trying to get academics to look into what we're doing on Bitcoin and Lightning and routing and everything, but it is very, very hard. So yes, there are lots of mathematicians and cryptographers, but right now they are not looking at Bitcoin enough.
Hopefully, the increase of the rate will cause them to look at it. But we are very happy to have you at San Francisco at any time. So thanks for coming, and we're looking forward to your technical talk, and good luck with ACINQ.
All right. Thank you very much.
Thank you.